Chapter 13, Sprint. The second event in Scrum is the sprint itself. This is the container for all the other events and all the work in Scrum, including sprint planning. A Scrum Master intends for the sprint to be creative, refreshing, and exhilarating. Because of this, a sprint is intended to run and end on a rhythm. The next sprint begins immediately afterwards with no time in between. Some organizations, as they introduce Scrum, may choose to sprint 2 weeks out of 4, spending the off weeks working on multiple projects at once and other non-Scrum practices. This may be required for new teams before all of management has transitioned to Scrum teams and monotasking. Some highly productive organizations will choose 2 weeks out of 4 and provide vacation time to all staff. The 2 weeks are used for team members to pursue their passion projects. Their own innovation, family time, and fitness. Tesla and SpaceX, currently 2 of the highest productivity companies in the world, work 3 12-hour days, then 4 days off. The following week is 4 12-hour days, then 3 days off. This provides the company 24/7 full-time around-the-clock operations while reducing burnout and allowing family time, fitness, mindfulness, passion projects, and other pursuits. To fit the entire product lifecycle, design, analyze, build, test, deploy, into a single sprint, large projects are split into smaller projects that may be independently designed, tested, and released. This is accomplished through modularity. Here is the modularity of the Boeing 787 as Boeing brings their company towards shorter sprints. The labeled modules by Boeing are labeled interfaces. There's material usage, there's a fuselage, the nose, the wing. The engines are separate modules, but interesting, they're not labeled. Trailing edge, tail sections, vertical stabilizer, rudder, horizontal stabilizer, and fuel tanks. Those are independent parallel groups from when I was working with the Boeing teams. The goal of where to split a module from another is to reduce weighting on anyone outside the team. Teams typically own only one module at a time in order to finish a tested version of the module each sprint. The modules themselves are split into submodules until they can be planned, analyzed, built, and tested within one sprint. Here is the modularity of the Wikispeed car, allowing globally distributed Scrum teams to iterate the car in 1-week sprints, starting in 2006 by Joe Justice. The modules here are aeroshell, interior module, chassis or frame, pedal plate or control module, front crush structure, suspension module, rear crush structure, drivetrain module. The purpose of modularity is to reduce weighting on anyone outside the team. Teams typically own only one module. Modules are constrained to be planned, built, tested within one sprint. And the goal of a sprint is to be less than a month, less than 30 days. Shorter is better. If you could do it in 3 hours, that'd be even better. Now that the teams have their scope of ownership, their module as an extra small project, they clarify what the sprints in iteration of the extra small project should be at sprint review. The intended script of what will ideally happen at sprint review this sprint and shared with all teams that share an interface as part of the group Scrum sprint review, group Agile sprint review, is written on a card as the extra small project for the sprint. This card is summarized as the sprint goal. An example sprint goal from Wikispeed was to compare Wikispeed's handling to the Honda NSX. The Honda NSX is a sports car, often used by automotive journalists as an example of a near perfect car in terms of how it feels when turning and braking, often called handling or sometimes driving feel. Whether this is objectively true or not is not nearly as important as the fact that journalists will use the Honda NSX as a commonly understood reference. Team Wikispeed rented a racetrack at the beginning of the sprint, and a larger racetrack and a professional Porsche racing driver near the end of the sprint. The team then added cards to the backlog. Each card was an experiment they could accomplish and test within the sprint. Each experiment was towards increasing the handling of the Wikispeed cars. Sprint goal: compare the handling versus Honda NSX. First, versus a unmodified NSX. An NSX is made by Honda. Second, versus a highly modified NSX, an NSX that had been turned into mostly a race car by groups of people who owned the NSX and raced it. And here is professional racing driver feedback. You can see the yellow top of the helmet of the pro driver in the Wikispeed car. This is on a closed racetrack. During the sprint, the teams attempted to create the shortest affordable feedback loop and iterate towards the sprint goal. In this sprint, the Scrum teams brought 3 cars to the racetracks. One Wikispeed car was raced on the track while the other Wikispeed cars were taken apart. New parts and software designed and built and installed, feedback received from the racing driver, and then the cars were switched to be race again. In this way, the weekly sprint was actually composed of 20-minute sprints at the racetrack. To be clearer, the feedback from the professional Porsche driver is debriefed to one team at the racetrack every 20 minutes using the sprint retrospective format. This was followed by an approximately 1-minute product backlog refinement. The racing driver then received an updated car to drive every 20 minutes, while the Scrum teams perform meta Scrum and sprint planning in about 1 minute to allocate the experiments to each team and begin working. There's a picture of Jackson Rudd using a Sawzall. It's a tool that can cut very quickly in many directions. He's cutting aluminum plate. It's the pedal plate on the front of the Wikispeed car. And the caption says, "This is a software developer." We work on the highest priority regardless of background. Work in pairs to increase quality. We suggest training goals for each skill required for delivery, not just one expertise. All work is done in pairs. In the photo above, Joe Justice is the pair of Jackson Rudd. Joe and Jackson are incorporating car driver feedback. The professional racing car driver requested a change to the accelerator pedal position for easier use while performing a performance driving operation called a heel-toe maneuver. In a heel-toe maneuver, the heel or back of the driver's foot applies to the accelerator at the same time as the toes of the same foot modulate the throttle rapidly and modulate the brakes, actually, modulate. Yeah, so you're on the accelerator pedal and you tap the brakes actually with your toes. And subtly to maximize acceleration and grip in a turn. Dabbing the brake shifts weight on the vehicle's front wheels, giving them more grip and more heat. And at the limit of adhesion, slides the front wheels slightly outward, while dabbing the accelerator gives the car more speed. And at the limit of adhesion, slides the rear wheels outward. In this way, a very skilled driver is able to turn faster by alternating between being too fast for the corner with the front wheels and back wheels, but never having all 4 wheels slide at the same time, which would cause the car to miss the turn and begin to slide off the racing track. Jackson Rudd is also the same person who led the team which programmed the basic machine vision and autonomous driving technology. This team connected the steering of the car to a high-resolution camera. The camera feed was processed in real time using several neural network libraries to identify the edges of the track. Then Jackson's wiring and electronics were used to steer the car automatically to keep it in its lane. This is the type of cross-training. This type of cross-training is exactly what makes the sprint very fun and very fast. Everyone becomes interested in helping each other and learns just enough to be helpful and eventually move towards being a black belt, the full stack, as described in Chapter 7, Roles. Teams. Teams swarm together on one work item at a time. The rule is no one is allowed to work alone. Pairs are the minimum. During the sprint, teams self-form around goals to complete their extra small projects. Here, Peter Borsella, stays near a group of volunteers designing and building a suspension module for the first time. Peter has designed and built other suspension modules as part of extreme manufacturing black belt training with Joe Justice. His job is not to know the answer to the team's problems or provide the best design, but to emote optimism and coach good Scrum as a Scrum Master. The key here is to help the team's morale stay high enough to arrive at a complete and tested solution, which will then create enough morale to carry the team through similar or even greater challenges the next sprint. Note, a team is often able to design and build some of the modules, for example, suspension modules and safety structures, in less than a day, even their first time through, with the help of posters on the walls of the Scrum room, giving engineering guidelines and tool and material use rapid introductions. Because of this, there are often multiple sprints a day per team, achieving what is called continuous release. In continuous release, the sprint end at the end of the week is conducted as a group Scrum review and a group Scrum sprint retrospective. All teams are invited to learn the current state of the entire integrated product. For more information on this, we invite you to see Chapter 15, Demo and Retro. We empathize with teams that suffer low morale from not releasing completed, tested products at the end of each sprint or more often. This is typically caused by a lack of modular architecture, which can be introduced as soon as the next sprint by a Scrum Master, and multitasking demands from management, which can be addressed through an executive-led agile transformation requested by the Scrum Master, who is also trained as a Chief Agile Officer via our executive-led agile transformation seminar. That is a run-on sentence. That looks like it should be 3 or 4 sentences. For more information on restructuring the company for speed, please see our seminar and book, Agile Transformation. Also, Chapter 16, Switch, in this book is quite deep. All modules are integration tested during Group Scrum Sprint Review, each sprint at a minimum, and teams typically call for integration tests multiple times per day during the sprint. For this reason, teams sharing an interface choose to work in the same room, where they can see or hear each other whenever this is practical. And there's a picture of a car put together in process for integration testing. The actual sprint backlog is typically about day-sized chunks of plan, analyze, build, test, and deploy. Adding these up meets the sprint goal, an extra small project. These chunks include meeting the definition of done, which progressively includes more and more test automation, marketing training, supplier cost optimization, customer feedback, and manufacturing automation, as the team improves their technical practices on the way to becoming a team of extreme manufacturing black belts. As automation improves, the sprint length can be brought down to about 3 hours, in which case the team has a very short version of the 5 Scrum events, like 1 minute each, sometimes 5 minutes. And the sprint backlog is typically empty or simple. Backlog. Here are real backlog items. In this case, they're drawings saying machine a metal bracket like this so it can hold this brake caliper in place. Then there's another drawing of another part to machine. Then there's small text saying, here's what I wish we had. Can someone figure out how to make it? Automate. Simulated tests run during design. The purpose of this is a rapid feedback loop, so we have better design and less regression, and more progress made for each design. The same teams write the product backlog together with their stakeholders during product backlog refinement and continuously throughout the sprint. These same people also perform basic automated simulation. As team members are increasingly cross-trained with CAD or computer-aided design, which is 3D drawing of parts to be made, they program automated crash testing to run real time on their CAD drawings. As team members are trained in CAM or computer-aided modeling, where a specific set of machines is programmed to automatically make that part from the CAD and raw materials, for example, sheets of aluminum, team members are add debugging scripts and automated tests. Team members are then trained in FEA, or finite element analysis, where crash testing is simulated and as shown in its most basic form in the picture above. Yeah, there's crash testing running here in its most basic form, frontal and side impact testing. And teams use this to update the automated tests. Team members are further cross-trained in CFD, or computational fluid dynamics, where heat and aerodynamic performance are simulated, which is used to further update the automated tests. Designers, of course, make their own product to receive a full feedback loop. All team members conduct all machine shop operations, where each team member is trained to drill, cut, file, deburr, mill, water jet cut, and order their own aluminum, drill bits, and other supplies, just in time from posters of best deal and best response suppliers posted on the Scrum room walls. Everyone is typically excited to work with high performance carbon fiber, and we all swarm to do composite shop operations, which includes designing, testing, and installing our own composite parts, as well as making mass production manufacturing processes for composite parts and executing those processes. For electronics, cross-train in basic embedded software programming, wiring, and basic project work with commercial off-the-shelf electronics and their sensors, including creating weatherized enclosures and installing them. In Team Wikispeed, we mostly used Arduino Megas, which were more processing power than we needed for cruise control, timing the turn signals, auto detecting dim light to auto turn on headlights, auto dimming bright lights, interior cabin lights, firing the airbags, etc. But we would use these $24 Arduino Megas, even though they were more processing power than we need, because there was no delay to get them. We could get them delivered same day, and we could order them in bulk, or we could order them just in time. And the programming languages and debugging and development languages for these Arduino Megas was well understood already by tens of thousands of people. We could go onto the internet and ask people to write code or update code or test code for us, unlike a custom circuit board where no one knows how to use it except the people in our company, and they have to learn and they have to make their own debugging tools and environment. So we used a standardized electronics platform, even though it was more processing power than we need. And overall, our total project timeline was far less expensive because of it. In this way, we have a full stack team, moving fast and having fun. Many companies had previously told Wikispeed this is impossible, that an electrical engineer could never be cross-trained to drill aluminum. For this reason, Wikispeed brought raw materials and tools to client sites around the world to participate in what is called a build party, where executives, managers, and engineers swarm together to build a Wikispeed car in one day. This has been so successful that many hardware organizations have then trained executives as Scrum Masters, then as Chief Agile Officers, to lead their own executive-led Agile transformation. For example, Bosch, GmbH. Electronics and software. It's easier to see the entire outside of the car, but of course, the electronics and software change every sprint also. This affects software architecture and supplier choices. Note that electronics and software are also updated every sprint as needed as well. With thousands of companies already sharing successful experiences of software iterations in 1 week or less, we will provide more hardware examples in this book. An example hardware sprint from inside Bosch GmbH. Thorben Hopke and Dennis Hein, two Agile coaches working as full-time Bosch employees, obtained their certified Scrum Master credential and then trained to become XM Black Belts with Joe Justice. This followed the work Joe Justice conducted directly with the CEO and chair of the board at Bosch, as explained in Chapter 2, Goal. Thorben Hopke and Dennis Hein returned to Bosch and mentored groups of teams internationally at Bosch, including setting up a facility equipped with standard tools and machinery, modeled after a Wikispeed Scrum room called Bosch InnoWorks. Bosch Agile Coaches. Large companies have full-time Agile trainers and coaches. On the right, that's Dennis Hein. On the left, it's Thorben Hopke, and in the center, that's me, Joe Justice. And we're in Bosch's InnoWorks in Germany. One of the teams coached by Thorben and Dennis identified a customer need on the front end of a heavy haul freight locomotive. Customer need on the front end of heavy haul freight locomotives. In Sprint 1, the teams attached an off-the-shelf Bosch part to the front of a real locomotive to receive customer feedback from real engineers actually using the solution in the train yard. Here it is, that's the stock botch part, and they machined a custom aluminum bracket and then connected it via wires to inside the cab. What the part is, it's a Bosch part. It's a rangefinder, a laser rangefinder. And inside the cab are parts similar to what Bosch makes for Daimler, Mercedes-Benz, and BMW, for parking sensors. So it shows the distance to an obstacle that the locomotive might bump. The Bosch teams theorized cars make great use of these sensors, maybe trains also could. So they set up this test rig in less than a week and put it on a real train actively used in a train yard. And what they found, the Bosch engineers theorized that the train engineer might find value when they're trying to couple with other cars, when they're trying to connect the train locomotive to other cars. The train engineers said, yes, we love this technology, please develop it, but it doesn't help us at all when coupling with other train cars. We're so good at that. We do that all the time. It's no problem. What that does help us with is when tools are left on the track, which the team at Bosch had never anticipated. The engineers said in the train yard, tools are left on the track every day, and you can't see them from up in the cab, especially when you're near the tool, because the vantage point is blocked by the nose of the train. And the tools get run over every day, and that typically destroys the tool, and sometimes it damages the track or even the train. And it's extremely expensive, and it happens every day. They said, your laser rangefinder is high resolution enough that it's letting us know where some of the tools are. But what we wish we had is wider dispersion so it detected both rails more accurately. So that was the feedback in sprint 1. That came from step 1. I worked with the CEO. Step 2, I worked with all the executives, more than 500 in speed rotations across 2 days. Step 3, Joe works with the teams making the products. And you can see sprint 1 here. Using this feedback, the teams then completed 4 more sprints for a total of 5 one-week sprints to have completed product ready to go to market. During these sprints, the teams developed and tested inside a railway museum where they could access an operating freight locomotive on a short piece of indoor rail track. This gave the team weather-consistent testing nearly 24 hours a day. This rapid feedback and co-locating design, analysis, build, test, and deploy allowed one-week hardware sprints, each having testable, usable product multiple times each sprint, in some cases more than once a day. The teams didn't just test in the Railway Museum, they also continued to put real parts more than once a week on trains in the train yard being used in the field. So they had actual customer field data and an even shorter feedback loop from inside the environmentally controlled train museum. And here's the next 5 sprints. Here's the next 4 sprints for 5 total. 5 sprints, new working hardware and software tested by the customer each sprint. Sprints are 1 week. The sprint 2, they found weather was interfering with the sensors, and they had 2 of these laser rangefinders now pointing at about each rail for the track. And they installed a wiper to help these sensors cope with weather situations. In sprint 3, they had even more laser rangefinders, so they had more coverage all around the front of the train to better detect tools and other small objects, and a larger wiper. By sprint 4, they were 3D printing their own enclosures. They weren't buying stock off the shelf enclosures anymore. And that allowed a smaller enclosure and smaller wiper, because by this time also their custom ordered circuit boards had arrived, which had more of these laser rangefinders on the same circuit board. So it was a more compact assembly altogether. By sprint 5, the custom software that they were making in team was good enough that it compensated for weather like snow and rain, and even the enclosure. So they no longer needed a wiper. By sprint 5, they went on sale. To accomplish this speed, each team Scrum Master measures the number of decisions that escape the team, as written in Chapter 7, roles. This allows the teams to iteratively identify what skills they truly need and incrementally build up automated business tests. Business tests provide a fast feedback loop. A fast business feedback loop creates more autonomy. A more autonomous team may be granted permission to make some procurement decisions in the team. Team procurement increases organizational speed of response. The Scrum Master guides the team to focus on impediments in value order, one by one, and eliminate their bottlenecks to speed. Agile native organizations do not have this constraint and can simply form according to Justice's law. The modules of the system define the structure of the organization. Joe Justice, 2006. Later in this chapter, we will explain this graphically. In either case, the destination for maximum flow and the shortest sprints in all types of work is modeled by Justice's law. Here I show a phase gate algorithm, a phase gate flow chart. This is from an actual client of mine, but the client's not named here. It starts with an overall project plan, and then it waterfalls into a phased approval for a marketing plan, and then that's gated as an approval gate to an updated business plan, then validated robust product, then field test, then technical services plan, then manufacturing and supply chain plan and execution and onboarding and contracting, then IP gathering, and then maintenance. The idea is each sprint actually has to include all these things. If your team can complete all these in a sprint without waiting outside the team, they are full stack. By avoiding handoffs like a relay race where different groups do different parts of these teams, we have the fastest and most complete response. That is business agility. We also have the fastest feedback loop for the fastest rate of learning. This is the goal of Scrum. This is a self-organizing team that is a complex adaptive system that is full stack towards their sprint goal. Conway's law. Any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. Melvin E. Conway, 1967. In 1967, Melvin Conway authored Conway's Law, which has been useful in organizational architecture ever since. Conway observed that the design of a product was limited to mirror the way people communicated inside the organization that designed the product. If the product had a separate project planning group that communicated at the beginning to a marketing plan group, the project would and should show inefficiencies from teams involved only at later phases, trying to meet a plan that was produced before the learnings from the later group. For example, the technical services plan. Process experts are able to infer the communication structure and organizational chart of the designing organization by examining the physical product. So if you look at an iPhone and you split it apart, you can learn a lot about how Apple communicates inside the company. That is Conway's Law, and it is very true. For example, if manufacturing and supply chain is not able to provide feedback into even the marketing plan and the overall project plan, it means you have a phase gate cascading waterfall where information learned later isn't able to be incorporated back into the overall project within a reasonable amount of time. With the emergence of even higher performance from full stack teams and group agile, Conway's Law rewarded us again. Joe Justice used the modular architecture of the product to backwards create a high flow structure of the company to design and produce the product. I've called this reverse Conway's Law and also Justice's Law. Again, the rule is the modules of the system define the structures of the organization. Joe Justice, 2006. I'm really proud of it. So I did put my name on it, and I do write when I wrote it. Here is what it looks like. Group Scrum or Group Agile, module teams, and they're supported by company as a service teams. Here, the product, a WikiSpeed car in this case, is divided into 8 modules. The organizational structure is then 8 teams or teams of teams, all integrating together in a group Scrum. The company as a service provides Scrum teams cross-trained to provide buildings to work in and funding and payroll. WikiSpeed was reminded by Silicon Valley companies it is important to provide hot meals as healthy and delicious as possible every 3 to 4 hours around the clock, and full-time 24-hour gourmet coffee drinks. The impact of morale and overall impact on velocity far exceeded the cost of providing these additional company as a service teams. Depending on the other backlog items, for example, legal representation, maybe another company as a service team can be either contracted out or full-time on staff, depending on frequency of need and depth of understanding required. To ensure the technical practices and engineering practices are shared effectively across teams, we recommend community of practices and quality circles as learned from Henrik Nieberg. Similarly, Paul Tacken rolled out tribes and guilds across ING Bank. Joe Justice has collaborated with both of these professionals, with Paul Tacken being one of the first certified extreme manufacturing black belts. A community of practice is an informal meetup of people with similar skills across all module teams. We recommend the Lean Coffee format by Jim Benson to most effectively run these large group meetings with an emerging backlog of what is most important to that group at that moment. These meetings are hosted as often as is helpful. In organizations that are not yet fast, defined as a release within less than 30 days, these meetings may be as infrequent as once a quarter. In extremely quick organizations, these community of practice meetings may be multiple times per day. A quality circle, as used in Toyota, is a more formal version of a community of practice. A community of practice happens at a specific time on a regular cadence, for example, every Wednesday from after lunch until the end of the shift. Teams attend if they believe they will benefit from the practices worked during the quality circle. Sorry, that should be a quality circle. Happens at a specific time on a regular cadence. For example, every Wednesday from after lunch until end of shift. Teams attend if they believe they will benefit from the practices being worked during the quality circle. For example, at Toyota, every product production line has painting operations. The line teams, like module teams in Team Wikispeed, all have some professionals that are building or have built deep expertise in painting. These people meet together with a formal expert, and these people work together on a refined backlog during the quality circle time box. For example, all these staff may visit one line and conduct an experiment on a new painting method to increase environmental performance of the painting operation. The attendees then collaborate to rapidly produce an academic paper on their experience and findings. The attendees then recommend an update to the standard operating procedures for all paint lines. Note, any work that may be written as standard operating procedure is to be automated as soon as practical. This is done in order to increase speed and to increase morale by continuing to eliminate any time the humans are not creatively solving problems. Then I have a picture of Tesla's marriage step, where in this case, a Model X is autonomously put together. Now, what's awesome about this is the parts these robots are holding change as often as every 3 hours. So the robots have flexible hands, and to make it simpler for the humans to design new parts, the interfaces are relatively simple to reduce cognitive complexity for the humans. For mass production, the module teams each own a lean production cell or module line, as described in Chapter 10, XM, Extreme Manufacturing. In this picture from Tesla, we can see this lean cell uses robots with flexible hands to hold a variety of parts. Part design changes multiple times per sprint. The parts themselves have stable interfaces, here as flat mating surfaces between modules. Stable interfaces allow any other dimension of the part to change without requiring a redesign of other parts that share an interface. The design teams are co-located with production, using production machinery for test, with the ability to rapidly roll back to previous known working designs. At Tesla, this is called Area 51, and this is where the leadership team physically works. This is the point of maximum rate of change, multiple changes in production per day. Actually, I learned a little bit more about this since writing this chapter. I wrote this chapter before I worked at Tesla. Area 51 is where their design is co-located with production, and it actually has grown to be all of Tesla now. And it has nothing to do with a leadership team, and there is not really a leadership team at Tesla. Tesla is almost entirely flat. There are roles like plant manager and health and safety officer to fulfill legal requirements, but whoever's in that role doesn't have more authority than anyone else. And in fact, who is in that role rotates. This helps keep the organization flat. The reason that happens is Elon Musk funds the operations. I mean, it's Elon's money, and Elon wants it to be flat. If Elon switched the CEO role or the funding role with someone who didn't want the company to stay flat, it wouldn't, which would then slow it down. You'd be waiting on approvals, waiting on design approvals, purchasing approvals, etc. So I believe that's the crux of it, that Elon is paying for it and Elon wants it to be fast. And Elon understands that self-organizing complex adaptive systems teams that are empowered, which is flat, then they don't need a manager, is faster. So that's what Tesla is full of. And that is Area 51. I write leadership team here. There's not really a leadership team that way. So let me highlight that. I'll see if I can change that. It's where all new product design happens, and that's everywhere all the time. This is the point of maximum rate of change, multiple changes in production per day. This point is also the bottleneck to higher volume and higher margin as modeled by the design, analyze, build, test, deploy value stream map. We hope this reinforces why Scrum Masters maintain the Scrum board for their module team with a column for each step in the team's current value stream map. The Scrum board shows in real time where the cards are piling up. Where the cards are piling up is a location of the bottleneck in the team's current flow. This also shows how the fastest companies globally operate their executive teams, working real time in the group Scrum at the point of work in the pattern called Area 51. Scrum Masters should be wary of organizations that prevent speeds across the organization by having an upper layer of the company, a hierarchy, that works on a slower cadence than the production teams. This is the structure of hierarchy that reduces the agility, the speed of change of the organization. Shorter iterations come from organizations where teams themselves make funding decisions, with the funders directly present in the teams in real time, as at SpaceX, Tesla, The Boring Company, Neuralink, and OpenAI. The only method for hierarchical companies with a quarterly strategic review to compete is to rely on large government incentives, which then protect the company from market forces. This strategy does work, but at the expense of excitement and morale, and the chemical brain cocktail that results from being on high-performing teams with short feedback loops. Preventing speed of change causes disengagement, resulting in lower reported managerial effectiveness, and further entrenching the internal company desire for a low iteration speed as the employees seek their engagement elsewhere after work. Employees then count down the hours until end of shift and the days until retirement, applying their best self and engagement somewhere else, and coming to work tired and slow. To break out of this circular malaise or slowness, executive teams join the Metascrum and then embed themselves in teams full-time using the Area 51 pattern. And eventually the executive team disintegrates, the funding machines, decision-making rights are pushed directly to the teams. This results in very fast-moving Scrum rooms of cross-functional team members, as seen here at Saab Aeronautics, Saab Defense in Linköping, Sweden. And this is a Scrum room making the Gripen fighter. The team members are writing code, they're machining new parts, they're machining new fixtures to make volume parts and test parts, and they're installing them on the plane. They're a full stack team. Saab in Linköping, Sweden flies planes every 3 weeks, as you saw in the earlier chapter, jets. And it's awesome and totally inspiring, and the people are really excited.